the equation to solve for the n for the break-even point. If the break-even point is, say, 4 years, would you buy a Prius instead of a Corolla? Yeah, well, because most people plan to keep a car for more than 4 years. So if the break-even point is before or at 4 years, it's definitely worth the money. What if the break-even point is 8 years? Maybe. Okay, it depends on your track record of how long do you own a car before you trade it in or buy another car. If the break-even point is 20 years, what would you do? Probably not, right? Okay, so just from the dollar and cents perspective, this will give you, it enables you to make a decision. Okay, should I go get this car? Should I go get the other car? And so on and so forth. You can actually do some shopping intelligently. Yep.
What do you mean by break even? How much money you spend on a car? What is the equation?
Okay, if you look at a graph like this, this is time, and this is how much money you have to spend on for the ownership of a car. Okay, a car can have a curve like this. The other car can have a curve that looks like this. This is the break-even point. Okay, if you plan to own a car only for this long, then you should definitely go for the car that has this curve. It's a sharper curve, but before it meets the other curve, you already sold your car. On the other hand, if you keep your car for at least this long, then you should keep the car that gives you this curve, because over a longer amount of time, the more expensive car actually saves you money in the longer run. Okay.
Costs more, but it costs less to operate, so you save money every year.
So now it depends on how many miles do you drive. Okay, what is the insurance rate of your Prius versus a Corolla? So you have to put all those into considerations to come up with these two curves, and then you can figure out where is the break-even point, and then based on your preferences, you can decide whether it is a break-even point that you think is realistic. That you can actually say, oh, I will actually definitely, or I have a high probability that I will be saving money, because there's a high probability that I won't have to upgrade my car until past the break-even point. But that's math, okay? Let's face it, it is math, and it is not math that a elementary school student can set up.
No.
Okay? Definitely not in this country, and I think not in most countries either. Okay? Now, you can also use math and statistics to understand the results of surveys, polls, and studies and whatnot. In other words, if I do a survey of this class, okay, let's say I'm I'm not teaching this class, I come into this class and I do a survey of what is the grade point average of students of this class up to this point. Okay, so I get about 10 students. 10 of you guys will answer a poll. I come up with a particular average. Okay, let's say the average at this point is people have a GPA of 2.5 at this point out of the 10 people that I sampled. But the class has 30-something students, right? And the 30-something students has its own average. The question is, how sure am I about the average of the entire class based on the average of the sample of the 10 students that I have? That's the question. Are you guys kind of understanding what I'm saying? Because I might accidentally have picked the top 10 students or the bottom 10 students, and therefore the mean of those 10 students may not be a good reflection of what the actual class is doing. Are you guys going to getting the idea? And now, how do I make that decision? How can I quantify the certainty of, oh yeah, I'm pretty sure the class average is somewhere between this and this number? It's all statistics, isn't it? Okay. So the first thing is, I'm not going to teach statistics in this class, but the first thing is, assuming the distribution is normal to begin with, okay, then, the standard deviation from these 10 students is going to be this much, and we know, based on, a normal distribution, the confidence level of within two standard deviations, left and right, is it 95% or so? There's a certain number, okay, but that number is actually calculated. So I can actually say with 99% or 95% certainty, I can pick the certainty amount that the actual mean of the entire class is from this number to this number. Okay, that is statistics. Okay, the more people I sample in the class, the more accurate that the mean of the sample is to the mean of the entire population, to the entire class in this example. Okay? Now, why do I care about this kind of math or statistics when I read the newspaper?
Well, with election polls and things like that, you're assuming people are going to make an opinion based on the results of the poll. But if the poll is biased or inaccurate because it's sampled from a
Right.
specific area.
But let's just say that I'm politically inert. I don't care.
All right.
I'm just switching brand of my morning cereal, right? I mean, who cares? I mean, what about medication? Okay, you go, you read up some newspaper, you read up some ads, and it says, well, according to our research, this many people who took this medication, ends up, being better. Okay.
Maybe you can read.
Okay, so the question is, are you going to get better because of the medication? What is the certainty that you will be, benefiting from the medication?
Right.
Well, statistics is important. Okay. What about going to the casino?
Yeah.
Huh? Okay. Now, I don't have any problem with people going to the casino if they have the mentality of, I'm going there for fun. I know I'm going to lose money for sure. I'm just going there so I can have some fun, watch the shows, work the machines, do a few, gambling thing. When I'm running out of my, allocated money, I'm just going to go home, go back to the hotel, have dinner and whatnot. That's fine. As entertainment, it is not, it's just like any other entertainment. But some people have the mentality of, maybe I'll get lucky and make money out of gambling at a casino. So, in that case, what is important? Math, statistics, probability, and so on and so forth. Because now, understanding the probability, someone can say, I know for sure that I cannot be winning on the average. Okay? I might be winning occasionally, but over the long haul, I'm going to lose money. Okay, so that is important. What about you're configuring a computer? You're buying a new computer, or you're making your own computer, and if you spend $500 more, the overall performance of your system will be increased by, say, 20%. Okay, so can you equate that $500 to the amount of time that you're extending the system's obsolescence period?
Yes. You went over that earlier.
Yeah, exactly. But is it important?
Yes. Yeah.
Okay, for people who has money oozing out of whatever, they don't care, right? It's like whatever. I will just spend the most money to buy a system that has everything. But to most of us, that is important. I want to spend my money wisely. I don't want to waste my money, just because for $500 I can make my system, stay at the same performance level for 2 more months. That's not worth $500 to me. Okay, maybe worth $500 to some people, but not to me. Is it important to figure out how much money you need to retire, or how much money you will have when you retire based on your current plan of retirement? Yes, it is, right? I mean, and the sad part is, the importance of retirement does not seem to kick in until people get older. Okay, young people hardly think about retirement. It's like, well, who cares about retirement? I want to do this, I want to do that, I want to buy this, I want to buy that. But in reality, it is actually the young people who have to think more about retirement than the people who are older. And that is because of what?
They can do something.
The growth of money is
Comes out.
exponential.
Yeah.
Okay, the growth of money is exponential. If you spend every single last penny, during the first 15 years of your career, and you put it all into investment or into retirement stuff, and assuming that you're doing average in terms of investment, you'll be, you have a big pot of money to begin with, and it grows itself. It grows exponentially as you continue to approach your retirement age. So, but what if someone decides, okay, when I first get my job, I just want to spend my money on sports car, a boat and stuff like that, and I will start to think about retirement like 20 years after I get my first job. Then that person will not have nearly as much time for that money to grow. So the exponential effect of growth, plays a very important part of how do you make sure that you will have enough money for retirement. Is that important? It is important. Does it involve math? Does it involve math that is beyond the level of an elementary school student?
Yeah.
Okay, very good. Now, for people who want to race their cars, okay, it is important to figure out the quarter-mile time of a car. So, how does a 400 horsepower engine compare to a 300 horsepower engine in terms of quarter-mile time?
Depends on the weight of the car.
Well, assuming everything else being the same, same transmission, same type of driver, everything else being the same, it is all a number game. So how much time are we talking about? It is not 3/4 of the time of the 300 horsepower car. It is to the square root of the 3/4. In other words, you're not buying that much time with a bigger engine. Now, of course, the other part of the equation is how can you reduce the weight of the car instead of increasing the horsepower of the engine? Okay? Now, that's a very important factor because most people will sneeze and laugh at the Miata. Okay? But if you put a turbo on a old Miata, like a 95, 94 Miata, it can crank up the horsepower to maybe 160, 170, maybe even 200. And most people would just laugh at 200 as a number. Because most cars today have at least 200 horsepower to begin with.
Right.
But then people are forgetting a Miata only weighs 2,200 pounds.
Yeah.
If you take out certain things, if you've got a Miata, it can get even lighter, right? So 200 horsepower for a 2,000 pound car is respectable. Okay, I'm not saying that it is going to be smokingly fast, but for the money that someone puts into a system like that, it's a good bang for the buck. Is that math?
Yeah.
It is definitely math. Okay. In fact, if for people who race their cars, one thing they look at is a curve that relates RPM to horsepower or torque. Okay. In other words, you're not just looking at the peak horsepower. Okay. Who cares about the peak horsepower when it's all the way over here past the red line? Right? If you have a car, and you look at the torque curve, it's like, oh yeah, we got some torque over here. Okay? I wouldn't drive a car like that. And the red line is here. Right? I mean, that's not going to be a very useful car to me. Because for the most part, it's slow, and then suddenly you get all the torque, and then you have to shift. After you shift, your RPM goes all the way down here again. Then you have to climb. Oh yeah, I'm getting some speed. Shift. Right? Is that important? For people who want to drive fast, it is important. Is it math? It's definitely math. Okay? This is definitely math. So then my last remark here is, the article would definitely get applause from credit card companies, lenders, casinos, and lotto operators. Because those are exactly the same people who do not want people to understand the math of everything. So that's just my pitch on Prop 69, which is continuing the importance of math education. It's a fake proposition, don't look for it.
Yeah, I was just wondering which one was that. I didn't see it when I voted this morning.
To me, that is more important than Prop 19 or Measure D or anything like that, because with a voting population that has a good training in mathematics, most of them will make the right decision. Okay, they will all kind of they will all kind of lean to the center instead of the left or the right, because most decisions will be based on money. It will be based on more pragmatic stuff than the more superficial stuff that people think about. All right, so that is that. It's just my little. I really